Hi and Assalamualaikum. Today we want to talk about vector and scalar. Our group members are Nur Maisara Balkis binti Muhammad Nurizi, Nur Ashikin binti Habidin, Nur Aina Natasha binti Syafi'i, and the last one is Nur Hidayah binti Muhammad Harun. Content that we have is vector expression, basic definition, basic vector calculation, operation of vector, and conclusion. Firstly, I want to talk about vector expression. The comparison between scalar and vector quantity. Scalar. Scalar quantity has magnitude but no direction. Vector quantity has both, which is magnitude and direction. Every scalar quantity is one dimension. Vector quantity can be 1, 2, or 3 dimension. Scalar. Any change in scalar quantity is the reflection of the change in magnitude. Vector. Any change in vector quantity can reflect either changing direction or a changing magnitude or change in both. Scalar. Any mathematical operation carried out among two or more scalar quantities will provide a scalar only. However, if a scalar is operated with a vector, then the result will be a vector. Vector. The result of mathematical operation between two or more vector may give either scalar, dot product, or vector product, summation, or subtraction. Example of scalar. Speed, length, area, volumes, time, mass, density, and energy. Example of vector. Displacement, velocity, acceleration, force, and momentum.
Okay, so I'm going to talk about basic vector definition, vector notation and representation. And as you can see, this arrow show the direction, meanwhile the leg A to B show magnitude. Symbol of vector is A and have arrow at the above, and then AB or small a and have arrow at the above. Vector can be presented as coordinate x, y, z, or in matrix x, y, z, or x plus y plus z. And then we move to our main point. This is independent vector. A vector does not depend on any coordinate, that it can start at any coordinate. Next point, that is position vector. Position vector is a vector start from the origin. This picture is origin. Our third point, that is equality of vector. This picture shows equality of vector, arrow A and arrow B. Two vectors are equal if both vectors have the same magnitude and direction, even though the starting point is not the same. For example, vector A equal B, hence A, B, and A modulus equal B modulus. Fourth point is negative vector. This opposite arrow shows the negative vector. Negative vector is a vector that has the same magnitude but opposite direction with the other vector. Vector negative is negative vector for A, but their magnitude are still the same. Negative A modulus equal A modulus. That's all from me. Thank you.
Basic vector calculation.
Now I'm going to explain about the question at exercise 3, page 140, chapter vector and scalar. I choose question number 3, which is, if you look at the question, if OM magnitude equal to I plus J minus K, and ON magnitude equal for I and plus 6J minus 2K, I'm gonna find Mn, magnitude of Mn, and unit vector of Mn. So first, here you need to find the Mn first. You need to MO plus ON minus it will be negative OM plus ON, and you should put the number of in the question, like 2I plus J minus K plus it will be negative and 4I plus 6J minus 2K, and the finishing answer is 2I plus 5J minus K. So now we're going to look at the magnitude of Mn. So magnitude Mn, you must put square root 2 square plus 5 square plus negative 1 square. You're going to get in the calculator 5.48. So the question C is unit of vector Mn. So you need to put the M into the formula. 2I plus 5J minus K, multiplication 5.48 it will be 0.36i, 65i, plus 0.912j and minus 0.182k.
I will be explain about operation of vector. Point A is school, point B is store, point C is house. From point A to point B with a displacement vector AB. Then from B to point C with displacement vector BC. The resultant displacement is A to C with a vector AC. The resulting displacement vector AC is called the sum of AB and BC. Now I will be explain about definition of vector addition. If U and V are vector positions, so the initial point of V is at the terminal point of U, then the sum U plus V is the vector from the initial point of U to the terminal point of V. We go through to triangle law. When two vectors are represented as two sides of the triangle with the order of magnitude and direction, the third side of the triangle represents the magnitude and direction of the resultant vector. And last is parallelogram law. Two vectors acting at the point are represented in magnitude and direction by two adjacent sides of a parallelogram. The resultant in magnitude and direction by the tunnel passing through the common tail of the two vectors. The conclusion is, vectors are used in engineering mechanics to represent quantities that have a both magnitude and direction. Many engineering quantities such as a force, displacement, velocity, and accelerations will need to be represented as vector for analysis.